Hello guys and welcome back to Leet Logics. This is the robot collisions problem from LeetCode and the number for this is 2751. So in the given problem there are n one-indexed robots, each having a position on the line length, on the line having a health and a motion direction. So we have n number of robots and each robot has a position on the line, it has its personal health, it has its movement direction, in which direction it moves. So we are given with zero index integer arrays containing the position, health and directions of the n robots. So these are the parameters given in these arrays. Now what the question says is that all the robots start moving on the line simultaneously at the same speed in their given directions. So suppose if two robots share same position while they move, they will collide. So if a robot collides with the other robot, the robot with the lower health is removed from the line and health of the other robot decreases by 1. While the surviving robot continues to move in the same direction it was going before. So if both the robots have same health while collision, both of them are removed from the line. Now our task is to determine the health of the robot that survived the collisions in the same order that the robots were given, and we have to return the final health of robots array containing the health of remaining robots which are left after all the collisions which are possible. Now a note is given that the positions may be unsorted of the robots. So this is a hint that we have to sort the positions of the robots. Now let's see through an example. So we have positions of the robot 5, 4, 3, 2, 1 and their healths are 2, 17, 9, 15, 10 and the direction is RRR. That means all the robots move in right direction. Since all the robots move in R direction and they have same speed. Since they have same speed, they will never collide. That means the health which is before the movement, that will be after the movement because there is no collision. So the health is the answer here directly. Now let's see for the second example. Now the second example I will explain you through the approach. So how we are going to approach this problem is that we are going to sort the positions, the robots according to their positions, and then we'll choose a direction. Let's say we choose right. So all the robots that are moving right, we'll put them into stack. And whenever we encounter a robot moving the left direction, that means earlier they were moving right, we encountered a robot moving in left direction and the positions are already sorted. Since the positions are already sorted, that means the particular element which is in the stack was coming before the current element. So there will be a collision. So it was moving right and the current one is moving left, there will be collision. So what we have to do, we have to compare whose health is less and we have to remove that. If both of them have same health, remove both of them. So let's see. Initially we were given positions 3, 5, 2, 6 and health 10, 10, 15, 12. Directions RL and index we have given it represented like this. So suppose we have sorted the array according to the position. So this positions array becomes 2, 3, 5, 6. Health becomes for 2th becomes 15th. 3 positions become 10, 5 position become 10, 6 position becomes 12 because it was like that earlier. And the direction is accordingly adapted. Now see, the first element is the 15 health moving in the right direction. So what we have to do? We have to put it into the stack. We have put it into the stack. There is currently no collision. So we can move ahead to the next index. Now as soon as we move to the next index, it is again moving to the right direction. So what we have to do? Put it into the stack, move to the next index. Now when we encounter the index 1, that is position 5, health 10 and moving in direction L. So what we have to do, we have to pop. For right we were doing push, for left we have to pop. Now we see which element is popped. So the last added element in the stack was 10 health, and this is also 10 health. That means they have same health. We have to remove both of them. So now updated health become 0, 0, 15 and 12. Since 15 is added into the stack and we haven't encountered 12 yet, so we come to the next index, the last index. Here the health is 12, it is moving in the left direction. Left direction means we have to pop. So it was having in the stack 2, 2 was having health 15. So what we'll do, compare the health, which one is less. So 12 is less. So what will be the health remaining? 15 minus 1, that is 14, which is the answer here in this case. So we can simply return the health 14 in this case. So let's now start with the coding section. So first of all, we have to determine the n, that is the length or the number of robots. So we can take it from the positions. This is positions dot length, and then we need a integer indices. We can take it as a integer, size is n, and we also need a list of integer to store the answer. So this will store the answer as the, so we name it as the result. And this will be a array list. In C++ you can take a vector, and we also need a stack of integer. So stack of integer stack equal to new stack. So we have defined all the prerequisites that we require for the approach. Now what we have to do, we have to store the indices in the indices part. So for that we'll store int I equal to 0, I is less than n, I plus plus. Now indices of I equal to I here in this case. Now next step is sorting according to the indexes, sorting according to the position. So arrays dot sort, so which we have to sort, we have to sort the indices we have to sort according to the positions. So we'll write a comparator in this case, LHS RHS integer dot compare positions of LHS with position of RHS. So this is the custom comparator that we'll need to sort the indices array according to the positions array. And the next step, we have to iterate in the indices part, and then we have to perform the operation of the push and the pops. So we iterate in the indices array. Now check. So what we have to do, if we were moving right, we were pushing into the stack, and if we were moving left, we were doing a pop operation if there was something in the stack. So first we'll write for the right. So if directions of directions dot char at, since direction is a string, so direction dot char at current index equal to r, then in that case what you have to do, we were pushing it into the stack. So push stack dot push current index. Otherwise, we have to check while stack dot is empty. While stack is not empty and health of current index is greater than 0. So in that case, we have to take the top index. Top index here was stack dot pop. Now we have to see if the top robot survives or the current robot is destroyed, or the current robot survives or the top robot is destroyed. We have to see all the conditions here. So for that, we have already written if health of the top index is greater than health of the current index. So here the top this is the position when the top robot will survive and the current robot is destroyed, because the health of the top robot is more than the health of the current index. So in this case, health of top index, we do a -1, and health of the current index becomes 0 because this is destroyed, and we put stack dot push top index. Now next we have to write for the case when the current health will be greater than the top index health. So simply we do nothing, take this condition, copy it, change the symbol. So here what will happen, so here we'll do a minus in the current index health, and we'll set the top index health to 0, and we will not put into the stack because this is the case where the current robot survives, and we have already seen in the else part that it is when we are moving left, so the left moving are not put into the stack. Now we also have one case remaining when both of them are of same health. So when both of them are of same health, we have to set both as 0. So set current as 0, set top as 0. This is pretty simple. And now what we have to do, we have to simply go and return our answer. So for that, we'll traverse the health array. I is less than n, I plus plus. So if health of I is greater than 0, we put it into the results. So result dot add health of I. Health of I added, and now we can simply return the health result. Let's try to run it for the sample test cases and see if there are any type errors. So yeah, we remove this. There is error here also. Let me fix some typing errors. So yeah, it runs fine for the sample test cases. Let's run for the hidden test cases as well. Passes with a good time complexity and a good memory complexity. So the time complexity for this solution is n log n, because we are sorting the indexes array. So the time complexity becomes n log n, and the space complexity is O of n because we are using a extra stack. So that's why. So this was the robot collision problem from LeetCode. I hope you understood the logic. Do like the video, share it with your friends, and subscribe to the channel if you're new to the channel. Thank you for watching the video. Have a nice day.